Okay, so members, let us see how we get the point of intersection between two planes. Now, for example, if I have plane 1 there and I have plane 2, it's that their intersection is through a line. So, two planes intersect through a line. Now, two planes, when you have this and this one, they are intersecting here. So, it's that this will be like this one. Now, find the Cartesian equation of a line of intersection of the planes. Now the idea here is 1. Always, you make x the subject in terms of y and also make x in terms of z. Then you get the 2. Now from here, if I put this equation 1 is that 3x minus 5y. If this is equation 1, then I have equation 2 as 2x plus z equal to 3. This is equation 2. Now, you see, eliminate 1 and you make x in terms of the r. So here I start, I can easily eliminate z by subtracting these 2. So if I subtract, you start will be having x. This will be negative 2 minus 2y equal to 2. When I subtract this side, I have 5. So making x the subject, so that my x will be 2y plus 5, and this becomes equation 3. Also now, you saw that I've made x in terms of y. Now, it means that now this time round, we eliminate y. To eliminate y, you start now you need to multiply here by 3. So I'm going to multiply 3 in equation 1. Then because the signs are different, I'll subtract off. When I multiply 5 in equation, we multiply 5 in equation 2. So 3 I have 9x then when I multiply here I multiply 5, so I have 10x then plus 5z equaling to 15. When I subtract, I have negative x. This and this, we have minus 2z equaling to this minus this, so that will be having a 9. So if you make x the subject, from here, so that your x will be, you first multiply it by negative, so we have having, now we take this side, we have 2z, now minus 9, and this one becomes equation 4. But now, you see that this and this are the same. X and x is equal to x and x this side. So from here, so that your x is equal to 2y plus the 5 equaling still, the x is still equal to 2. This is negative. This is negative when I take everything aside. When I take this side and I bring x this side, equal to negative 2z minus 9. So, you see that I'm saying, if you check that the coefficient is not 1, you multiply by the reciprocal of the coefficient up and down. So this, you know that all of this is over 1 and this is over 1. So from there, my x will be now 2y plus 5. We said that all of this should be 1. So if it's not 1, you multiply by the reciprocal of the coefficient. So the times the reciprocal there, which is a half, over 1 times still a half. You multiply it up and down. So this will be equal to 2. This one is also negative 2z minus 9 over 1. Because this one is not 1, so I multiply by the reciprocal of negative 2. So it will be negative a half. The reciprocal of negative 2 is negative a half, up and down. So now we simplify. My x will be this time, this will be having now y plus this time, this which is 2.5, the whole over a half equaling 2. Now negative and that will be having now z. Now this and this will give me now a plus 9 over 2, the whole over negative 1 over 2. Now we have expressed it into the Cartesian form. Some people, by that this point is going to vary, but the entire vector is going to be the same. Now you see that our power vector here is 1 half and negative a half. So you see that this one is parallel to, when I factorize out a half, you see that my power vector will be a half into 2, 1, negative 1. So this side can also be a spiral vector. So because it's spiral, so this is the line. Now I have, this was just an example. If they asked it, if they wanted the line in the vector form, in your vector form, you would say, now your arrow will be, you get a point. Now it's that this x is 0, then this will be negative 2.5, this will be negative 4.5, then plus lambda into, now this is over 1, which is 1 half, then negative half. That will be the vector form. Now remember, there is a second approach of how you can handle this number. The second approach of handling this number. Look at this approach, members. The second approach, to get this, because you know you need the vector equation of line. This, to get this vector equation of line, you dot this, you dot the normal to this plane, and you dot, you cross the normal of this plane and the normal of this plane. So now you the line you want, you cross the normal one and normal 2. Let us see what we get. Our normal one is 3, negative 5, then 1, then we are dotting it, we are crossing it with 2, negative 3, then a 1, which will be, let us see if we cross. If we cross, when I cover the first, I'll be having negative 5, then minus, which will give me a negative 2. Then when I cover the middle part, I'll be having 3. Remember, we have a negative raise. When we come to the this, I'll be having 3 minus 2, which will be 1, but it's negative because of this negative. When I cover this, I'll be having negative 9. Then this and this will give me then minus, which will give me a 1. And start from here, there is a common factor, which is negative 1, which will be 2, negative 1, 2, 1, 1. And negative 1, if I remove out a negative 1 out there. So you see that now, it's the power, it's the power vector we have here. Now, from there, it means that now my line is equal to A plus lambda u. But my u, I have it right now, I'm ready to get the point. Now, remember after us eliminating from here, is that what all we had x equaling to, x is equaling to 2y plus 5. Now from here, if I let my y be a 1, if my y is 1, then x is going to be, so my x is going to be a 7. So if y is 1 and x is 7, you can easily come and get the value of z from here. So from here you can get z, because this is x from there is 7. Then when I take this side of here, now plus 9 equaling to negative 2. So when I add this and this, you see I will be having 16. So negative 2z. This will be giving me 7 plus 9, that is 16, divided by 2. By negative 2, I will be having negative 8 as my z. So from here, I start your z value is negative 8. So after getting the measure now, this point here will satisfy the line. So now you start our line, there will be a point which is now 7, 1, negative 8, then plus lambda u, the parallel plot which is 2, 1, negative 1. And you see that this one, the point is going to change, but the power vector is going to be the same. This is the same. Why? Because if you factorize out a half, as I showed you here, factorize out a half, we are having 2, 1, negative 1. Here I factorized out a negative 1. That's why I had a 2, 1, negative 1, which will be the same. So that's the second approach, but it's rare. I wish you the best.